Okay, so we're now going to use knowledge of graphs and our understanding in order to interpret what the graph is telling us. So right here we have a graph on this right hand side, and whenever you're first given a graph, it's important to look at the y-axis, so in this case distance from home, and the x-axis, which in this case is time. Okay, so that means as I go up, as I increase my y, I get farther away from home. And then as I move along the right, or my x gets bigger, more time has passed. So now we have three situations here on the left. So we need to match which situation is going to match with this graph. So Tom took his dog for a walk to the park. He set off slowly and then increased his pace. At the park, Tom turned around and walked slowly back home. Okay, so far it looks okay. It says he went slowly and then increased his pace and then he turned around. So this point is obviously where he turned around. And then if we look at this point, well, that's where he changed speed, right? From here to here, he's going pretty quick. And then from here to here, he doesn't go quite as far. So one might be a possibility, but maybe not. Let's check the rest. So Tom rode his bike east from home up a steep hill. After a while, the slope eased off. At the top, he raced down the other side. Now this one's just trying to trick you. As you look, you can see it's trying to make you think of it, but we don't know like where he was riding, right? We just know about his distance, and so 2 is not going to be a possibility. So then we have 3. Tom went for a jog. At the end of the road, he bumped into a friend and his pace slowed. When Tom left his friend, he walked quickly back home. So this is probably a pretty good situation. The only difference is in this one, he started slow and then went fast. Okay, whereas in 3, he started fast and he then went slow. So I think in order to know the difference, we look at how it's increasing. Here we see that this is increasing very quickly, whereas here it increases kind of slowly. So based off of that, if he started quickly, right, and then he started to go a little slower before he went home, 3 is going to be our answer. Okay, next one. So we have another graph. Once again, we look at our axes. So the y-axis, distance from home, x-axis is time. Okay, so Tom left his home for a run, but he was unfit and gradually came to a stop. So, I mean, he left his home, so that's good. He started at home, and as he ran, it starts to flatten out until he reaches here. And there it looks like his distance is not increasing or decreasing. It's like he stopped. So number 1's a good option. So let's try number 2. Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground, but then sped up again. You know, I don't feel like that one kind of fits it, right? It doesn't show anywhere where he slowed down and then sped up. In the case we're looking at, he basically is slowing down as time goes on. And then opposite Tom's home is a hill. Tom climbed slowly up the hill until he reached the top. That one's just a distractor, right? It says hill, so you're like, oh, it must be a hill. But remember, we're not caring what the graph looks like of the picture. We're trying to interpret, well, as the y goes up, I get farther away. And as I go the right, as my x gets bigger, I get more time. So our correct answer for this would be 1. That's a good situation for the story. Okay, next one. So Tom went out for a walk with some friends, moving at a constant rate. He suddenly realized he had left his wallet behind. He ran home to get it and then had to catch up with the others. So this one's a pretty interesting one. So he started at home. Well, look at our y-intercept. Did he start at home? Well, no. When he started away from home. So obviously 1 can't be it. 2. After the party, Tom walked slowly all the way home at a constant rate. Okay, that's a possibility, right? Because he started at the party and then walked home. And then number 3, Tom skateboarded from his house, gradually building up speed. He slowed down to avoid some rough ground, but then sped up again. Well, once again, he did not start at his house. so we know our answer is 2. I do want to point out this word constant rate. That means it's going to be a straight line, okay? A constant rate is anything with a straight line. If it's curved, that means it's not constant. It means he's either slowing up or slowing down or speeding up. So a hint is whenever you're reading this, if you see constant rate, it means it's going to be straight line. Okay, our last one. So I'm going to read through them all and then try and pick which one you think it is, and then I'll tell you which one it will be. So Tom took his dog for a walk to the park. He set off slowly and then increased his pace. At the park, Tom turned around and walked slowly back home. Tom went out for a walk with some friends, moving at a constant rate. He suddenly realized he had left his wallet behind. He ran home to get it and then had to run to catch up with the others. Tom went for a jog. At the end of his road, he bumped into a friend and his pace slowed. When Tom left his friend, he walked quickly back home. Take a second, think about which one you think it might be. I'm going to say it would be number 2. Okay, the reason why is he went out for a walk with some friends in constant rate. So he's walking along this line. He's walking, right? He's getting farther away, and then he left his wallet behind. Now, it doesn't say where. Okay, he doesn't say where he left his wallet. So the fact that he had to backtrack, right, this means he's going back. The distance from home is getting smaller. That means he must have left something, right? And then he went and had to catch up with the others. So I would say 2 is our answer for this one.